Hello, and welcome to a little video about Target 1C, arithmetic and geometric sequences. Alright, first, let's warm up by determining the pattern here. Take a look at number 1 and see if you can figure it out. What it looks like to me is we're multiplying by 2 each time. So let's multiply by 2 3 more times. We've got 720. 1,440, and 2,880. Can I zoom in some more? I can. Beautiful. All right, number 2. Check out the pattern, see if you can see what's happening. Oh, that's the bell. That's fine. I won't restart. We're like less than a minute in. Hopefully you didn't hear it, but if you did, that's fine. All right, for number 2, what it looks like we're doing is we're adding 2 each time. So let's add 2 each time. 4, 6, 8. All right, check out number 3. Can you tell what that pattern is? It looks like we're multiplying by 3 each time. So we got negative 162, negative 486, and negative 1,458. Number 4, can you tell what the pattern is? It looks like, I'm multiplying by negative 3. Let's fill out the rest. So we got negative 324, and then we'll have positive 972, and then negative 2,916. For number 5, can you tell what the pattern is? It looks like the pattern number 5 is subtracting 4. So let's finish the pattern. We've got a negative 40, negative 44, and negative 48. All right. Now, hopefully you noticed that we had some patterns that had multiplying, some that had adding, and some that had subtracting. Well, arithmetic sequences are sequences of numbers in which a constant is added to each term. Now, subtracting is the same thing as adding, but we're adding a negative number. So, subtraction is still an arithmetic sequence. Now, the pattern in arithmetic sequences is called the common difference, and we use the letter D for difference to denote it. So let's take a look. So I got a little example that got cut off, but you should see that our numbers are getting smaller in the worked example. That means we are adding negative 2, or if you want to think about it, we are subtracting 2. Therefore, the common difference is minus 2 or negative 2. So those are synonyms. Oh, my spacing turned out weird, but for number 1, I guess we'll answer above it. My bad. Let's find the common difference for this one. So we've got 3, 11, 19, 27, 35. Now let's say you're not that good at mental math. Let me show you how we would figure this out without having to do mental math. What we're going to do is we're going to take term 2. Let's write it out in words first. Term 2 minus term 1. Well, term 2 is 11. Term 1 is 3. So what we have is 11 minus 3, which is 8. So our common difference is 8. Oh, I forgot to do D equals. Perfect. Anytime we have an arithmetic sequence, the common difference can be found through subtraction. Now, if we have a geometric sequence, so something that seems to be going up or down faster than addition and subtraction, is going up or down through multiplication. Instead of calling it the common difference, we instead call it the common ratio, but we represent it with the letter R. Now, division is the same thing as multiplication, except you're multiplying by a number less than 1. So when we get a common ratio that's a number less than 1, or like a fraction, that means we're dividing. However, just like subtracting is technically adding a negative, dividing is technically multiplying by a number less than 1. All right, so for example, here we have 1, 2, 4, and 8. We're multiplying each term by 2. The common ratio is 2. Let's find the common ratio to the sequence. Now let's say you're not good at mental math. How would you find this? You would find it by doing R equals term 2 divided by term 1. So let's check that out. Term 2 is 16. Term 1 is 32. So 16 divided by 32. If we do that in our calculators, we get 1/2. So our common ratio is multiplying by 1/2, which we can also think about as dividing by 2. All right, let's see if these patterns are arithmetic or geometric. Now, the way we do this is by experimenting. First, I try to see if there's a common difference that holds up. If that doesn't work, I try a ratio. Okay, so term 2, term 1. I'm going to start with finding the common difference and see if it holds up. So common difference would be term 2 minus term 1. So that's -8 minus -10. Let's see if that works. All right, -8 minus -10 is +2. So possibly we're adding 2 each time. So I know that happens between -10 and -8. -8 plus 2, is that -6? Yes. -6 plus 2, is that -4? Yes. So it's arithmetic. D equals 2. Woot. Let's try that for number 4. Now, as always, I like to start with arithmetic. Let's see what happens. D equals term 2 minus term 1. No, I wanted term 2 in pink. Thank you. And term 1 in green. Thank you. Okay. So that means 8 minus -4. Eight minus -4 is 12. Well, let's see if that works. Is 8 plus 12 -16? No. Okay, it's not arithmetic. We still have to make sure that it's geometric, because what if it's neither? So, common ratio, term 2 divided by term 1. So this time we have 8 divided by -4, which is -2. Well, let's check it out. Is 8 times -2 -16? Yeah. Is -16 times I don't know why I almost wrote 12, times -2 32? Yes. All right. So it's geometric. R equals -2. Cool. Now, let's take a look at 2 patterns, or 2 prompts for patterns, and we'll set them up. All right. Write the first 5 terms of each sequence that we have described. All right. The first term of the sequence is 8. And the common difference is 12. Common difference means add. Okay? So we got 8. 8 plus 12 is 20. Oh, I want to color code it. Blue. Plus 12. Plus 12. How many do we want? The first 5. So we're going to add 12. So 1, 2, and then 3 more times. Okay? So then we got 32, 44, and 56. In number 6, the first term of our sequence is -5. And our common ratio is -2. This means multiply. Right? So we got negative 5 times negative 2. Then we got to do that 4 more times. I'm just going to prepare. Times negative 2. Okay. Negative 5 times negative 2 is 10. Times negative 2 is negative 20. And then positive 40, negative 80. Oh, I went too far. 1, 2, 3, 4, 5. Yay. All right. So that is a little difference between arithmetic and geometric sequences. If you have any questions, please let me know. And have a wonderful rest of whatever day it is for you. Bye.